All right, now this one is from homework number 11, confidence interval part 2, question number 15. So let's take a look at this one. Find the margin of error, for a 95% confidence interval for estimating the population mean. So we can usually do t-stat, right? Oh, I'm sorry, t-test, or I'm sorry, t-interval, right? T-interval. But I think this one's a little different. So let's be a little careful. When the sample standard deviation equals 110, with the sample size of 400, and the second one, they're going to ask you to increase the sample size to 1764. What is the effect of the sample size? So we're answering a couple different questions here. First, find the margin of error for 95% confidence interval for estimating the population mean when the sample standard deviation equals 110 with the sample size of 400. Now, they never told you what sample mean is, right? So we're not really creating a confidence interval. We're just finding the margin of error. Now, let me go ahead and find you the formula real quick that you will need for this. Give me 1 second. So if you go to 8.2, let's see. Scroll down a little bit. Let's take a look. That's for proportion. Oh, sorry. 8.2 was about confidence interval to estimate per population proportion. We're going to need to go to 8.3. I forgot 8.1 was an introduction. So 8.3 is where you want to go to. And I will also send you the link to this Google slide so that you can look at the formula yourself. Let's scroll down a little bit. Here we go. Around step number 4. Okay, right here. You will need to find the standard deviation of a sample mean. It's called standard error. Okay, the margin of error is going to be now we use z here, but we're gonna need to use t. So let me find that one for you. And I hope you remember when we use t versus z. I'll find that. Aha, here we go. So this is the confidence interval formula. And what we need to focus on is this piece right here. The x bar is the sample mean. X bar is the sample mean. We don't really care about creating the entire confidence interval here. We're just trying to find out the margin of error. And the margin of error goes as the critical t-score, t-value, multiplied by the standard error, s divided by square root of n. And we should be able to find what this number is. We were given what sample standard deviation is, and we know what the sample size is. So we're just going to do this. We're multiplying this number by a quotient of these two. So let me go ahead and open up my Word doc so that we can start typing in what we have, okay? Now, first of all, let me explain to you why they are saying t and then this 0.025 over here. Now, what you want over here is a 95% confidence interval, right? So take a look. If you want 95% confidence interval, you want 95 in the middle, right? My calculator jumping up and down. If you want 95 in the middle, how much is to the left and right of it? 100 minus 95 is 5, right? Now, listen. When we use the t distribution, and I'm about to go and use that t calculator, we can use, because this is two-sided. If you can imagine, let me try to, I don't think I can draw a picture, but if you divide this 5 by 2, what we are saying is 2.5%, 2.5% is to the left of this confidence interval, and 2.5% is to the right side of it. And 2.5% is in decimal 0.025, 0.025. That's why they have this t of 0.025. We're talking about 2.5 percentile on this t distribution. And for 95% confidence interval, that is the number that we're going to have to look up. Okay, so let me go ahead and start typing in the things that we need. And once we figure out all these things that we need to multiply, formula itself isn't that complicated at all. So I'm gonna do it this way, but then I will try to see if we can use technology, StatCrunch, to make it a little bit. There's like a shortcut or something like that. But I'm gonna do it the regular way first. The critical t-score that we're gonna need to look up is this, and we're going, whatever that is, we're going to multiply this by a fraction, right? Of standard deviation divided by square root of n. Okay, and notice they did, if you want to use t distribution, you need to tell them what the degrees of freedom is. And degrees of freedom is simply going to be n minus 1. Remember from class we talked about whatever the sample size is, you're going to have to just subtract 1, and that is your degrees of freedom, okay? So let's go ahead and go back to the problem and write down everything that we know. But this is the formula that you're going to need to use to find that margin of error, okay? So let's see over here. They gave you a whole bunch of things. First thing that I noticed they gave us is the standard deviation. Sample standard deviation equals 110. So what we know is that S equals 110. For the first problem, S equals 110. What else did they give you? N. They gave you the sample size, didn't they? Sample size is 400. N equals 400. And we'll do the same thing for the other sample size. But we got S and we got n. Now, you and I will now look up this critical t value on t distribution. Okay, so let's go to StatCrunch to use t calculator. Okay, if you go to, I wish I have StatCrunch open somewhere. Maybe I closed it. I have one right here. So if you go to StatCrunch, let me delete all these. Go to Stat Calculator and T, and tell them that the degrees of freedom is going to be 1 minus your sample size. Let's see, what was your sample size? Sample size was 400. So what you're going to enter is degrees of freedom is going to be 399. It's always one less than your sample size. Now, keep it the same. Type in that number 0.0. No, I'm sorry, the other way around. 0.025 on the other side. So what we want is, what is the t-score? What is the t value that will have 0.025 to the left of it, okay? If I go ahead and click compute, it's going to tell me that the number is going to be 1.965. So I can just go ahead and round it up to negative 1.9. Now, let me be very careful there, because you know how particular they are with rounding. So 2 decimal places what they want. So let me just be very careful and write down like 4 numbers. 9, 6, 5, 9. I'll just do it that much, okay? Now, we got everything we need. So I'm going to go ahead and multiply. I'm going to go ahead and plug this into this formula, okay? So the number that I got, and if you're worried about like, oh, we got a negative, it doesn't matter. Because the margin of error, remember, is what we add and what we subtract. So we're going to add 1 and we're going to subtract 1 anyway. So if you just want to use positive of it, that is fine too. 1.9659 times, we're going to have to multiply this by a fraction. The standard deviation they gave us was 110. The sample size was square root of 400, wasn't it? I'm sorry, the sample size was 400, so that's that. So 1.9659 times fraction 110 over 20. Now let me just grab a calculator and type this in. We're about to find the margin of error. 1.9658. 1.965. Let me just do it over here. 110 divided by 20 is equal to 5.5. So I just need to do this number times 5.5. And that is going to be our margin of error. This times 1.9658. So the margin of error will be approximately 10.8119. Okay, 10.8119, and round it to 2 decimal places, we can type in 10.81. 0.81. Check. Awesome. Now, I think that one was a little crazy. It's a little crazy because what we did in class is, we just started with the data or summary. I mean, this one was just finding the margin of error. That's why we had to kind of go back to the formula and do it. But I think I have an idea. How about we do a little, let's do something a little different, okay? I think that you may like this method better. And honestly, I don't know if it's going to work, but I'm going to try this, okay? So take a look. We usually do these confidence interval just by going to stat and t-stat. T-stat, why? Because we don't know population standard deviation. We got sample standard deviation. So if you don't know population standard deviation, we have to go with t-stats. Go ahead and click on one sample and what summary. Now let me show you what we have available. We know that the sample standard deviation is 110. And we also know that the sample size is what? 400, right? Now, the reason I can't do this, do this method is because nobody gave us the sample mean. But if you remember, when we were finding that margin of error, did we use sample mean anywhere in our problem? We never did. We never really did. So who cares what the sample mean is? I'm gonna make up a random number. I just type in 200 there, okay? I just made up a random number and typed up 200 there because nobody really cares about the actual confidence interval. I just want to get the margin of error. Let me show you something. I'm going to click compute. All right. Now remember, we talked about how the margin of error is how much you add from sample mean to get to the upper limit, and how much you subtract get from the sample mean to the lower limit. So let me show you what I'm going to do here. Okay. I'm going to go ahead and do upper limit minus the sample mean. Upper limit is 210.81. 210.8126, and let me go ahead and subtract 200, my random sample mean that I just typed up. Guess what? It comes out to be 10.81, right? So what I did was I just picked a random sample mean because all I cared about was the margin of error. And this isn't probably it. But at least the margin of error formula, they don't really care about what the actual sample mean is. So we can just kind of, it's like a little trick method, right? It works. You know what? Because I think looking at that t-value can be somewhat, annoying, really. So let me go ahead and do the other one using this very tricky method, fun method. How about we find the margin of error for 95% confidence interval for estimating the population mean when the sample standard deviation is 110. That stays the same, but they raise the sample size to 1764. Let me do that. Okay, you may like this method better. I'm gonna go to stat, t-stat, and one sample with summary. And here, over here, we know that the sample standard deviation is 110. And then the sample size, we just raise it to 1764. We were never given sample mean. Like, we don't know what it is. But as you know, if you're just finding the margin of error, we don't care about what the sample mean is. You saw that the formula for margin of error only includes critical t-score, the sample standard deviation, and the sample size. So you make it up. What's today's date? Today is the 25th. So let me be random and put 25 there. And I'm going to go just compute. Now, if I want to find, whoopsie, I accidentally did the hypothesis test. Let me go back and click on confidence interval, okay? I clicked on the wrong thing. Stat, t-stat, one sample, with summary, and then over here, let me just pick a random sample mean. Standard deviation was 110, and sample size is 1764. And then go ahead and click on confidence interval for mu, and they wanted 95%, so let's compute it. Now, the answer is not here. We're about to find it. Now, listen, margin of error is going to be upper limit minus your point estimate, okay, your sample mean. So what we're going to do is, once my calculator pops up, take the upper limit and subtract it by your sample mean. I'm going to do 30.136766 minus 25. The margin of error is going to be 5.14. 5.14. So I didn't want to do that critical t value. I mean, we can do it this way, but I just kind of made up my random sample mean and did it. Now let's compare these two. Everything stayed the same except for sample size, right? So listen, the standard deviation stayed the same. 95% confidence level was still 95. But how did we just almost cut down that sample size, margin of error to almost half of it, right? It used to be 10.81, but when we did it with a bigger sample, we cut it down to like 5.14, and that's better, right? Isn't that better? We got smaller margin of error. So what is the effect of sample size on the margin of error? The margin of error is the same for all sample sizes. No, it's not the same. The larger sample size, it decreased the margin of error. That's what happened over here, right? Now listen, as you know more about the population, we're less likely to make a mistake. So as you increase the sample size, we're going to be a little more accurate in our confidence interval. So you can say increasing the sample size will decrease the margin of error, and that will be the answer for this question. I think we can come up with different methods to use our StatCrunch, backward, sometimes. Even if you are not given every given, like I wasn't able to type in what the sample mean was when I was trying to figure the first two parts out, but because they were never given, but we can still kind of made it up. And once we notice that the formula for margin of error only really requires standard deviation and the sample size, so we really didn't care about what the sample mean was unless you really wanted to find the entire confidence interval. But in this problem, we were only interested in finding the margin of error. This one took some time, but I think I got one more question that you emailed about. I will go ahead and go over that one now, okay?